Okay, welcome back, everybody. Let's get started. So today we'll be kind of covering all the basics you need to complete homework 2. Homework 2 will be like a simple tree layout that you'll be doing with the D3 stuff that I'll be teaching you about and some of the JavaScript things. And so what, like last time, we've covered HTML and CSS. Today we'll be covering SVG, scalable vector graphics, the graphics format that we'll mostly be working with. Then do like a JavaScript introduction. And then we might jump ahead to the first steps in D3. This is kind of like the essential stuff that you need for the homework. If we have time, we'll go back to talk about interactive DOM manipulation using the standard API. And I might talk a little bit about running in a web app. But those things, if I don't get to them, we'll cover them eventually, or you can just read up on them. Any questions before we jump into SVG? Great. So as before, you can go to dataviscourse.net/tutorials and follow along. Great. So so far, we've only seen textual content in HTML. But of course, this is a data visualization course, so we want to do graphical content. And the method of choice for this course will be scalable vector graphics, or SVG. This is like a subset of the HTML5 standard that essentially lets us draw pictures on in a browser. SVG is super powerful, it's widely supported, and it's very easy to program for. It's also the preferred target of D3, the library that we'll be using. So D3 and SVG just work well together, though like you could use D3 with anything else as well. Alternative methods for drawing something on the screen are Canvas and WebGL. And those are really cool libraries, or cool kind of like technologies as well. But they tend to be like a little bit more, if you want to do high performance computer graphics, you would be using WebGL. If you like, Canvas is something in between. It's kind of like a pixel-based drawing approach. It's also fairly fast, but it doesn't have this vector graphics idea. So like you draw in pixels in Canvas, but you draw in vectors and shapes and so on in SVG. So that's kind of the big difference between those two. And SVGs are like infinitely scalable, right? So they're like always precise. I can zoom in, and I will always I will never see any pixelation. So and SVGs are also nicely work into the DOM. So all of the SVG things that we'll learn will actually use elements and attributes and all of this stuff. Okay, so here's the most boring SVG that you can do. Our minimal example here. This is kind of like the only thing we do is we add an SVG element with a certain width and a certain height into our HTML. And this isn't particularly surprising that this doesn't show anything. But if we inspect in our inspector here, we see that there's indeed an SVG with the width of 400 and a height of 200. So not particularly exciting, but like it's all it is another element, right? And it has some special attributes, width and height. Great. So let's look at a circle. We want to draw a circle. This is our goal here. Draw this circle here. We have again, and like by the way, I was kind of particular about including all of the HTML boilerplate before, just so like this is like the way to do it. But from now on, I'm essentially like only doing anything between the body tags here, right? Like this stuff that just saves a little bit of boilerplate and makes the code a little bit easier to read. Okay, so here we have our SVG. Again, width and height of 400 and 200. And then we specify the parameters of the circle. It has the center at X position is at 200, and the center Y position is at 100. And then we define the radius of 50. And then finally, we define a style. And the style here is fill gray, stroke steel blue, stroke width 5 pixels. So this is like the contour here on the side is the stroke width. And so this was our very first like SVG that actually made sense, that actually drew something. A couple of things that you will notice here. First, it's slightly weird that if you look closely, or if you thought back about the CSS attributes that we specified before, they're actually incompatible with what we do here with style, right? So essentially, one thing that you have to keep in mind is that the styling for SVGs is like completely independent of the styling for CSS, right? So they might sound different sometimes, but most of the times they're actually not even related, right? So for example, fill here is what background color was in CSS, right? So, and there's some sense in this because it's really like a drawing format, right? It's not a web styling format, but it's really like I want to create graphics with it. But of course, it can also be fairly annoying. Okay, so the other thing to note is that the SVG coordinate system originates from the top left. So if we draw a sequence of circles starting at 10, 10, 40, 40, 70, 70, this is what we get. This is our first circle. This is our second circle. This is our third circle, right? And that's kind of sometimes it's convenient, but sometimes it's not so convenient, right? Because if you wanted to draw a scatter plot, we probably want the origin to be at the bottom left. And so we'll look at some method that we can actually use to make this a little bit more convenient. Okay, so then I already mentioned these presentation attributes. The presentation attributes can be quite different from what we have in CSS for HTML. We can also do something in SVG that we can't do in CSS or in CSS for HTML. So we can also specify graphical attributes here as attributes. So we, instead of saying style, fill is gray, we can say fill is gray, right? Why is this kind of like, why does this make sense here and didn't make sense for HTML? Why can I do this here? Well, because in HTML, we were trying to essentially separate presentation from content, right? But if we create a graphic, there isn't really any point in separating style from content, right? So the style is really like essential to the SVG element. And so that's why this is legal to do in SVG. Yeah, so here is an example of the difference that I mentioned earlier. So we have the like two things here. We have a div that we style with CSS. So this is like the traditional HTML way of drawing something. And this is just a little rectangle. So we give it a width, we give it a height, we give it a background color, we give it a border style and a border color. And we make it look like like a rectangle. So it's actually not really distinguishable from SVG here, right? And then we draw the circle here as an SVG element. And notice really the differences in how I specify this, right? I specify an X and Y position, I specify a radius, and then the rest of it I specify with fill, stroke, and stroke width, very different from what I had before, like border style and so on. The other thing that is different is that the title, like the tooltip element, is on hover, like that makes this appear on hover. That is an attribute in HTML, but it's actually a nested element in SVG. Again, slightly weird, right? There could be reasons for that. I'll get to this eventually, maybe. But in the end, it's like if the result is the same. So if I hover over the circle for a while, I will see that information. Okay, great. Oh, and another thing is like it's kind of like, you know, of course I could draw a circle with CSS, but it would actually be fairly complicated, right? So I would have to do some fairly crazy magic to do that. Well, not really crazy magic, but for some things like more complicated shapes, it would be very challenging to do this with CSS, which is then, of course, easy with SVG. So, for example, another shape that we have available in SVG is an ellipse. And an ellipse, of course, has the same CX and CY position, like the center of the ellipse here is specified. And then we have a radius in X and a radius in Y, right? And those can be different, and hence we make this an ellipse. And if you wanted to specify an ellipse that is like slightly off kind of center, we would have to rotate it, right? So like if you didn't want it to be elongated exactly horizontally or vertically, we would have to go in and rotate it later. Okay, the next important shape here is a rectangle. And for the rectangle, we specify the X and the Y position, and then the width and the height. And so the X and the Y position, we can look at this, are the top and the top left corner. So X0, Y0 is the top left corner. And then width and height, of course, are like as we expect. The width is like here 200 and height is 100. Yes? So the coordinates are local to the SVG. And the SVG can be placed, for example, with a grid layout in somewhere on the page, right? if I have like the SVG is really what we're drawing on here. So for example, if I push this over to 500, you wouldn't see it anymore. This like 500 would be somewhere around here, but our SVG is only 400 wide, right? So the coordinates are always relative to the position of your SVG, which is kind of convenient, right? You can like plop everything that you need into one SVG, and that's your view. That's where you render, and then you can position this on a page and put some toolbars or title at top of it. You would. That's very common. So you would put an SVG in a div, and you would position that somewhere on the page, right? Yeah. Well, the margin is actually there from the SVG. So if we can look at this, and like so basically it's actually like if I can't really show this. Well, I can. Okay, let's do this. So here we have our specified our SVG, and if we move this here to 0, 0. Okay, what you'll see is the blue thing that I'm hovering over here is our SVG, and it's precisely at 0, 0, right? The white padding that you have on the side is actually because the SVG is padded a little bit, and it's just like the default padding that a div or some container has. It would not. It like if it wouldn't. It would be like if I put in negative coordinates. I actually don't know whether it works, but we can try. Let's say minus 50. So you can see it's clipped, right? So it's outside of the SVG, and we can't see that part. Yes. So that's a good question. It's pixels, but yeah, pixels aren't what they used to be. So pixels back in the day, before we had high resolution displays, were really like hardware pixels, right? But nowadays, pixels are some like a display, and an operating system specifies a hardware pixel to software pixel ratio. And that's just, you know, otherwise it would be like really weird to use an 8K screen. Like you would basically not see anything, right? Everything would be squished. Everything that has been designed with pixels in mind would be squished on some side. And so what you do now, even if you have an 8K screen, you still have some kind of like more manageable size of pixels. It's software pixels. So it's kind of like, you know, what you specify on the web, on a browser, is always the software pixels and not the hardware pixels. So if you have, for example, like a 16K display that is this big, you can still, like, even though you have like thousands and thousands of pixels, you can still use the same pixel coordinates as you would on a regular screen, because your operating system does this abstraction for you. Yes. So you can, of course, in HTML, but in SVG you can't, and it doesn't really solve the problem, right? Because you, like in SVG, you want to draw precise, and so it's just a unit, right? Think of it as an abstract unit, and you just like have to look at it where it is, right? And relative to your positioning of the SVG. The other thing is, of course, pixels doesn't mean pixels, because I can zoom into an SVG, right? At arbitrary like resolution. Like if I zoom in here, you will never see any kind of like pixelation appear, right? So the pixels don't match to screen pixels anyway. So just think of it as pixels, but as like a convenient pixel screen concept that you can dynamically adjust. I can link an article that I just read about this, because I was wondering myself. I kind of had a rough idea, but it's kind of weird, right? Like if you have a phone that has more pixels than like my screen in 2005, it's kind of a weird concept to still use pixels. Okay. Great. So let's see. I think I did this already. Yeah. Great. So in addition to rectangles, we can draw lines. Like nothing particularly fancy. One thing that we can do, as we did before, we can use class definitions for styles. And here, this is the same syntax as for CSS, but you have to actually use the terms for SVG, right? So it is CSS, but it is CSS targeting SVG. And so you would use the stroke black here, and that would apply. And so here I can say line class is lines. And then for a line, I specify an X1 and Y1, an X2 and a Y2. And I have these two lines here that start at 30/30 and 50 and go to 280. And the second line, 30/50, it goes to 150 and 120. Okay. We can also specify text in SVG. This is something that we commonly want to do, right? So for example, if we want to label something in a scatter plot, we want to draw text on top of it. And we don't want to do this in HTML, but we want to do this directly in SVG, because then we can use all of the same coordinates and so on. And so like very helpful to specify text. So for example, here, the text is specified with the text element. We also position it by X and Y. Notice this is like a fundamental difference that like in HTML, we mostly do floating stuff, right? We write a div and then it has a height, and then the next div or the next paragraph has like it lays out the text. In SVG, we do almost all the time static positioning, right? We say things are at pixel 30/30, right? And we do this also for text. And so I can do things very easily, like for example, have those two things overlap. That is a completely like easy thing to do in SVG, and so you have to take a little bit more care of this. Yes.
But does it specify the bottom left corner of the text, or?
Well, good question. Let's. I'm sure it does the upper left corner like everything else in SVG, but we can look. Oh, no. So yeah, it seems to do the bottom left corner. Yeah. Great. So these were some of the basic shapes, but of course, like, well, you can do like a lot of stuff with just lines, rectangles, ellipses, and so on, but you can't do everything. And so to break out of this cage, we have the path element, and the path element essentially lets us draw arbitrary shapes, arbitrarily complex shapes. And the path element is essentially like a mini language. And so I'll explain that mini language to you. In practice, except for in homework 3, you won't have to write any path code yourself, because usually like nowadays we use libraries to generate path code for us, right? So for example, we tell D3, create us a nice path based on this data set. We don't really write it, but of course you need to be able to debug it, and you need to understand it. Okay, so this is what we want to do here. The lower part here is the lower part of the code here is just these circles. They're just for reference. So like what we really want to do is this curve here that has these kind of like straight lines and then this curve here, okay? And so here's the specification. This is really where the magic is happening. And let me explain to you how that works. So what we have is essentially 4 key commands. We have the move, the draw a line, the close the path, and the curve command. So move essentially think of as like me being a robot. And if I get a move instruction to go to pixel 1010, I take my pen, but I don't hit the paper, and I just move there, right? And then I get an instruction to draw a line to 50/50, and wherever I am, I just put down the pen and I draw it there, right? So it's always in relation to the previous point. So move is kind of move the cursor, the virtual cursor, to that point without drawing a line, and L is move the cursor to the next point, but keep kind of like pressing down on the paper. So that's the idea. Z or Z closes the path from the current position to the first element. So for example, if you're drawing a rectangle, you can go like go from here to here to here to here, and then you don't have to specify go back to the origin. You can just say close, right? And it will automatically close the element here. And then C is the interesting bit because it allows us to draw curves. There's many different curves. C here is an example for a cubic Bezier curve. And so let's look at this code here. So we have our M2020. So that means we are moving from origin here to the point 2020. Then we have L6020. So we go over to 60 and 20. So like that's a horizontal line because it has the same y coordinate, right? So and we're drawing on that line. Then we're going to 60, 60. So the the x coordinate stays the same, but our y coordinate changes, and this is what happens here. Then we're going to 11060. So our x coordinate changes, but the y coordinate stays the same. This is what happens here. And then we're going to 11020. And so we end up at this point here that I labeled with origin. And then then starts the interesting part, the curve points. And the curve, if you know anything about Bezier curves, then you will know that they have kind of like, a beginning and an end, but they also have multiple support points along which they snake, right? What we specify here are these support points. So we have like support point at 11060, one support point at 16060, and then the end point at 160 and 20. And I've illustrated these here with little circles, right? This is our first support point here. This is our second support point here. And this is our third support point here. So for example, if we change this here to 180, the line would still, or the curve would still kind of like end up in the same place. But it would kind of like the support point would be somewhere different, right? And so the curve would look different. Yeah. Yes, exactly. So yeah, we can try that, and like it's kind of like hard to wrap your head around what you're drawing here, but we can add another point here, and then we'll eventually get somewhere. Yeah. But yes, you should be able to add more support points. I'm not completely sure on the details of the cubic Bezier curve, so we would have to look up the details in the documentation. Okay, great. There is an MDN path tutorial as also for SVG, just as for HTML. MDN is like the library of choice, and you can do like lots of different things here with curves. You can kind of like learn how to specify the various curves, and there's different curves available and so on in this tutorial here. Great. So in any graphical library, you have to worry a little bit about ordering because you might have elements that overlap. And the rule in SVG is simple and maybe sometimes frustratingly simple, right? So for example, like here, I'm throwing an ellipse in the rectangle and they overlap. And the rule is whatever appears first in the DOM gets drawn first. And whatever appears afterwards gets drawn on top of it, right? So it is not like there isn't a depth, like a principle of depth. It's just the order of drawing it. Why is this frustrating? Because sometimes you want to kind of like change an appearance or draw something on top of it. And so if to do that in D3, for example, you have to like introduce concepts of layering. So that, for example, if you want to highlight something, it has to be like a separate function, typically, that you call at the very end. Things like that you have to be careful about. And so if we invert this, that we start off with the rectangle and then draw the ellipse, we see that the opposite here appears. Okay, so the next concept I want to talk about is grouping and transforming, and because these are super useful principles. So if we have, for example, points in a scatter plot, we might want to draw them with respect to one origin, but we might also want to draw scales and labels. And like one thing we could do is we can always take each point, and let's suppose we want to draw the point at pixel 50/50 relative to the coordinate system, but then there's a padding on the left because we'd want to draw the axis and the labels and the ticks. And so we would have to add 20 pixels or so to it, right? And that's, of course, annoying. And so what we instead want to do is we want to put all of our points into one group and move this one group together. So we can kind of like keep a local coordinate system. And so here's like a simple example of all of those things here are together in one single group. And we can also use the group to kind of globally define some attributes. So we can say everything in this group here gets to get the fill steel blue. And so we can see that this here is now all part of one group. And this really like is particularly useful if we combine it with geometric transformations. And so again, there's plenty of complicated things that you can do with geometric transformations, but the basics here are these translate and scale things. So for example, if I wanted to create a scatter plot I might want to like start at the origin 0, 0, right, at the bottom left. And so I kind of want to invert the coordinate system so that I can draw this neatly. And I can do that by taking this group and saying, translate everything by like 200 pixels in Y, and then scale all of the Y coordinates with -1. And so what this does here is basically it takes the Y, the outer Y, takes the 200 and subtracts the inner Y, because I have kind of the inner Y, I've multiplied it with -1, right? So it's now a negative value. And by doing that, I get kind of like this coordinate system here that I've flipped upside down. And so that's kind of like neat to do. Now I have coordinates, for example, this pixel, this point here, if I want to move it up to 70, 50, over to 70, 50, I change the X, it kind of is exactly what I wanted to do. If I want to move it up, it also works, it goes up, right? So that's like a neat trick. The most important piece here is actually like the translation, right? Because as I mentioned, if I had some kind of like padding on the left, I could just translate this over by 20 pixels and I can still use my local coordinates within the group. Okay? And so the translate is super useful. You will use this all the time. The scaling has one downside. So one of the downsides is like this applies to everything, including text, right? This here reads, this is how they read text in Australia. And clearly this isn't what you want, right? So if you wanted to label your points in your scatter plot, you wouldn't really have a choice other than dealing with this in some other way. You could, of course, write a function that does this for you in JavaScript. Okay, great. So that was SVG introduction. Any questions before we move over to JavaScript? Yeah. Yes. Great. So then let's start programming. Sure. Yes, you can nest everything, right? Great. So so far we haven't really programmed, right? We have only done like essentially markup languages and kind of like graphical languages, but we didn't have any if conditions and for loops, no functions or anything like that. Now we'll be programming. And so for this tutorial, what you should do is go into your, if you want to follow along, open up your developer tools and open up the console. And then this button here will be a friend because this clears the console, right? And so every cell here, or most cells here, will create some output and it will print it to the console. And if you just like, after you've executed it, clear it, you get a good sense of what is going on. Okay, so JavaScript, like from the survey, I learned that most people here know Python. And so Python is kind of like a language that is in many ways similar to JavaScript. It's dynamically typed. But the good thing about JavaScript is really that it works with the web browser, right? It's a programming language. It's a fully fledged programming language. It can do what other programming languages can do. But the thing that only JavaScript can do is manipulate websites and manipulate web applications for that. And so this is really nice. And JavaScript has kind of like a storied history. Does anybody know why it's called JavaScript? Yeah. Exactly. So back in the day, there was a hype around Java. And so they developed this new programming language that had nothing to do with Java whatsoever. And just because Java was so popular, they called it JavaScript, right? But it doesn't have any kind of like, resemblance. It's actually quite different from, it's much more similar to Python than it is to Java. And so JavaScript has been really bad. Like back in 2010, it was like a terrible language. But like stuff on the web generally, there has been a lot of effort to standardize, and it's gotten a better language. It still has some of its quirks, but it does some things pretty nicely. And there's some historic craft that you have to work around, right? There's usually now ways to work around them, but you have to use some uncommon like syntax. For example, you can't use a for in loop, but you have to use a for off loop because the for in loop was misimplemented basically back in the day, and for compatibility reasons, they kept it around. So little things like this, but everything since 2016 basically is like actually pretty good. And also you will see that browser compatibility is pretty good, and people are nowadays updating their browsers. Like when I first started developing something for the web, we still had Internet Explorer 6 and things like Silverlight and so on, and you really like develop for one browser. And nowadays it's fairly easy to develop cross-platform. So the other thing to note is, I said earlier that you really can't manipulate websites unless you have JavaScript. That's of course true on the client. There is two exceptions to this. There's some, well, there's actually mostly one exception to this. There's WebAssembly, which is kind of like this idea of running other programming languages in the browsers. This is still better. I think will still be a while until this is useful. And then JavaScript, I also said that it's mostly used for web front-end development, but in fact, you can also use it for back-end development with like services such as Node.js, which kind of like makes it easy for full-stack developers because they're in one environment. But I think still most people use JavaScript on the front end and Python on the back end as an example. Okay. And then JavaScript is a multi-paradigm programming language. So it can be used in an imperative procedural way. It can be used in an object-oriented way. And it can be used in a functional way. And so we'll be actually using like all of those, but a fair bit of functional programming, because D3 really encourages functional programming. The other thing, like Python, it is, and unlike C++, C, or Java, it is a dynamically typed language, right? So you don't define your data types, but the data types are essentially assigned at runtime. This has certain pros and cons, as you will learn. There is an alternative to JavaScript that's called TypeScript. TypeScript is kind of like, you know, this language that is eventually transpiled into JavaScript, but that has static typing, and that had also some of the features that JavaScript didn't have back in like 5 years ago. TypeScript had things like modules and so on that JavaScript didn't have. JavaScript has come closer to TypeScript. Still, I think all of my PhD students and everybody in the company that I co-founded works exclusively with TypeScript, right? Just because for large software projects, TypeScript is the way to go. You still want to use, like, you still want to really understand JavaScript if you want to do web development, and we'll be using only JavaScript in this class. And the weirdest thing of all of JavaScript is probably that it uses prototypical inheritance. So for its object-oriented programming aspects, it doesn't have, well, it has classes, but it actually doesn't implement it as classes, but it's prototypical. So what that means is that you don't have a class that you instantiate, but you have a prototype object that you basically copy. And we'll be going into this. So this really, like, all of this was meant to be meaningful for people who have kind of studied programming languages a little bit, but don't know JavaScript yet. Okay, let's take a look at the very basics here. As I said, like these cells, you can run them. They don't show anything except for in the console. And so if you just like enter space anywhere here, it will re-execute. As soon as you change something, it will re-execute. And then something here will appear in the console. And then in the console, you can either type clear, or you can hit that button. The button here is, of course, like more convenient. So any of those is, and if you then hit space again here, then it will re-execute, and you will see it again. Okay, so first thing we do here is console.log message, and we see that message appear, console.log, and then we do some mathematical expression, 22 divided by 7, and we will see that result fairly close to pi. And then we also have like libraries like math.pi will show us pi here with more precision. Okay, so very simple. And like any programming languages, JavaScript has variables that hold values. So these are like examples for global variables. So for example, here I'm assigning A the value 0. Then I am assigning B the string 1. Then I'm creating an array, and arrays look just like, you know, arrays in other programming languages. Here, Paul, John, Ringo, and George. Then I created another array, a numerical array in this case, with like years in it. And then the thing that is weird about JavaScript, I can do this. I can do these kind of like hybrid arrays. So I can have like 2 of the elements be numbers, the 3rd element be a string, the 4th element be another array, right? So that is completely legit. Generally, this is not a good idea, right? So you should keep your arrays, or the data structure arrays, meant to be of the same type. If you want a data structure that has a diversity of types, you should use an object. Then we have Booleans. Lowercase f is false. If you could also say true here. And then we can, for example, check types. So if we run this here, we get to see the type of f is a Boolean, and the type of f here that we specify with 34.56 is a number. Okay, so far this is all easy. Notice again that Java is dynamically typed. You don't need to declare any types, and you can also change the type. So as you see here, first f was a Boolean, and then I changed it to a number. And so like there is no history of it, right? Like if just because it used to be a Boolean doesn't mean it has to be a Boolean the next time a loop comes around, right? For example, because you might have changed it. Okay, so the thing is that it can be tricky to that you like. One problem with this is that you could kind of like have a typo in a variable assignment, and this won't be caught, right? So I can write something like whatever f is t, and well, this what do I want to do here? So basically, it's kind of easy to do things wrong here. So to mix things up because of this dynamic typing. But if you have a good IDE, you can do this properly. Syntax highlighting in a good IDE will help you catch many of these problems, but it's still something that you have to be aware of. Note that all of these elements here were global variables, right? So I didn't specify any scope, and I didn't specify even that they're like a variable. And so they're global variables, so they will be available on this website in the global namespace. And you can kind of like get around this with local variables. And so there's these types of local variables here. There's the var attribute, which is kind of like the pre-ES6 ECMAScript 6. This is kind of like the fancy name for JavaScript. So ECMAScript 6 and later is kind of like what we typically use nowadays. And everything before that is kind of like, old JavaScript. And before ECMAScript 6, we had the var function scope variable. And that's kind of, well, I'll talk more about the function scope, but that was the way to do it back then. Now we have the let, so this is like let age be 36, right? That's kind of like the variable definition for locally scoped, block scoped variables. And I'll talk more about the distinction here. And then also new in ES6 is that we have constants. So for example, I can define a const nationality and say Austrian here. And this here will actually throw a type error. So if I try to reassign this, this will actually like result in a runtime exception. And so the thing, like in all other programming languages, const variables are like immutable at the top level. But if you have a complex data container, they're still mutable, right? So if I have like a const test here and that has these element 2, 3, and 4, I can modify test by assigning a new value like 9 here, and this will still be mutable, but I can't reassign test to another array, right? So this is like, similar to all other programming languages. Okay, so let's talk about these scope things. So we had global scope. Global scope means that a variable is really like available to everything on the top browser level. var creates function scope, and function scope is something that is not common in other programming languages. That means that, for example, here we have like a demo for the function scope. We have a variable a that we define in this function here. Then we have an if clause. We define a variable b. And then outside of that if clause, outside of this block here, we can actually access variable a and variable b. Like most programming languages won't let you do that, right? They will, like you will be able to use variables like only at this, or like you won't be able to use a variable that has been defined in a narrower scope in like a wider scope, right? So variable b shouldn't be really accessible outside of here. But it actually is accessible if you do the var definition. And that's the difference with the let definition. And the let definition is more in line with what most other programming languages do. It uses block scope. So if I do this here, let A be 2, let B be 3 in this if clause here. If I try to do this, you will see that this actually tells me uncaught reference error, let B is not defined, right? Which is kind of what we want because we're not now polluting our namespace outside of it. And so var, function scope, let, block scope, generally always use let, right? And don't think too much about it. And then the other thing is that global scope, even if I define a global, like a variable in a function, I still have global scope for that variable if I don't use let or var. So this here, for example, means that, let me comment this out again and clear this. And if we run this again, we can see that this global A that I'm accessing here in global scope is actually accessible, even though I only defined it in a function, right? So generally, this is something that you should never do if you want to define global variables. That's okay to do sparingly, right? If you have something like some global state, we can talk about whether this is good programming or not, but it's okay to do it. But you should never define a global variable in a function. Yes? The var one is not global. The var one is local to the function that it's defined in, but independent of an if or a for loop or any other thing. So if I define a var in like a 3 times nested if, it will be available anywhere in the function, which is different from let in a 3 times nested if. If I define a variable there, it will only be available there or deeper, but it won't be available up higher. Okay. So always use let, never use var, minimize your use of global variables, and don't define global variables in functions. So here is like some basic operations. We can add, we can subtract. We have this. Because it's just bad programming. Like you can, but it's terrible programming practice. Because like if you define global variables, you should have this somewhere like in a definition file or somewhere at the header, right? Here are my global variables that I want to keep track of. You don't want some function that you maybe include in a library suddenly define a global variable. I'll give you an example. If you use an whatever, like my name string, like this is your global variable, right? That let's suppose you include a library that you haven't written. If that library were to pollute your global namespace, it might actually override a variable that you have defined. And so just to keep kind of things separately, you want to minimize global variables. And if you have global variables, you want to keep them in one place where they are all together. Okay, so we have this like add assignment operator. We have the plus plus and the minus minus operator. We can divide. We have a modulo operator. Everybody know what a modulo operator is? Or no, let's ask it the other way around. Sorry. Who doesn't know what a modulo operator is? Okay, we have a few people. So it's kind of like you divide by that number and then you get the rest, right? So it's kind of the remainder operator. So that essentially, like basically that tells you, that would be here. If you do modulo 2, if you have 1, you had an even number, an odd number, and if you had 0, you had an even number. So you have a type of operator, which can be useful, of course, especially for debugging. You have string concatenation. You can say 2 words here, and then you can see that it actually like half the 2 words here appear as 1 string. You now have template strings, which is the better way of like, or maybe the more readable way of doing kind of like complicated strings. So you have this backtick, previous results, colon, and then this is the part here where you access a variable. You have a $, curly brackets, and then the variable, and then you can keep typing something else here, right? And so you get this very human readable thing and can kind of combine it, and you don't have to do this plus concatenation of strings. Then you have a parse int operator. So here I'm parsing the string 13, and that will be converted to a number. And if we look at it, we can actually see that this is indeed this number here. If I do a parse float, I will get my float number here. And if I do parse int on a float string, I will of course get an integer, right? So here basically I'm doing like this implicit cast from the string 17.5 to the integer 17. We could kind of like do the other thing is this shorthand parse operator that is super common. So like it's very common. So for example, if you load data from a CSV file or from some resource, everything that you get is text. There's no data types, right? And so very commonly do you have to convert this to numbers. And so this is very common to just use this plus operator. And that means take the string that follows and convert it to a number. And that's basically like a parse number operator. So the shorthand parse operator. Any questions about operators? So if I understood you correctly, you were asking why we use the $sign in the string, but not anywhere else. Because in other places, we assume that things are either variables anyways, or they're defined keywords, right? Like in other programming languages, it's either like an if or like a while, or it is a variable name. And so we don't need the $. That would just be additional syntactic sugar. But in here, we don't actually know what the variable would be, right? If I write just diff result here, that would be kind of weird. And so that's why I have the $, curly brackets. And then I tell it, this is like now substitute anything between the curly brackets with a variable. Yeah. So this one, yes, this is not a quote. This is this backtick. So the one that's like on your keyboard left to the number 1. And it's not a quote. The quote won't work, right? This is like the template string. This is a new introduction in ECMAScript 6. So if I had like a regular quote in here, this wouldn't do it, right? So here we would get previous result is diff result. So that's not compatible. Again, this is a thing that, to not break backwards compatibility. If anybody has ever used a $sign in any string, that would kind of like throw up all the old code. And that's why they use this different backtick syntax here for these template strings. And so if I replace this with the backticks again, then I have my, and I see my previous result here. Okay, yeah. Any variable that you can read in that scope. So if it's a global variable, if it's accessible, it will be here. If it's not accessible, you will get a runtime exception. Okay, let's talk a little bit more about arrays, because we'll be working a lot with data, obviously. And so we can define arrays, and you should think of arrays like if you're familiar with C. In C, you have to manage a memory, and arrays are really like a low-level data structure. Arrays in JavaScript are more like in Python. They're actually like, lists. And so you can extend a list. You can pop elements of a list. You don't have to worry about allocating space. All of this is done for you. So I can define arrays in the syntax. I can define an empty array like this. And I can log an array. The nice thing about well, here I'm retrieving a value from an array. The nice thing about using the console logs and using any object is that these debugging tools now are actually pretty good, right? So this here is the array representation. This tells you it's an array of length 5. It shows you the elements, and you can even jump in and look at this and inspect all of the variables. And that is also true for any object, right? So if you just print an object, you kind of like have this nice debugger built into the console. So print object will not just print the string representation, but it will now give you like a discoverable state of the particular object. Okay, so this like I can access variables in an array by index starting at 0. And then I can have this multi-type array that I already mentioned. This is possible, but not recommended. You can access the length of the array using the length attribute. So like just saying my array.length, that will give you the length. You can nest arrays, and this does make sense, right? So you can have nested arrays, and then you would just access them, for example, with the first is like first step, like I'm accessing the second array here and the first element of the second array. So I would expect that this here would print 3, right? First element of the second array is 3. If I want to extend an array, I can just push to it. If I want to override an array at a particular point, I can just do that with the square brackets notation. A push also returns the new length. So if you wanted to store that, or if you wanted to inspect that, you can do that. You can pop like from a stack that removes the last array and the last element of the array and returns it. And then you can also find the first index of a particular option. And so there's many things that are like many utility functions that are defined on top of an array. Index_of is one of them. What would you expect if I have this array here? What should num_array.sort return for this array here? Ascending order, starting with 3. And what does it do? Exactly. So if you just do sort, it sorts it alphabetically, right? So it will return, in this case here, 12, 15, 21, 3, and 4. That isn't, of course, what you want in this case. And so what you have to do is you have to give the sort function here another function that does a comparison of numbers. So here we have our function compare numbers that just gives us returns a minus b. Just by the logic, if a is smaller than b, this will be negative, hence it will evaluate to false. And that's like if we like, and then here is this kind of like thing that we'll be talking more about later. We pass compare numbers, this function here, now as a parameter into the sort function. So we can take a function based on its name and pass it into another function as a parameter. So I can actually assign functions to variables, which is a very cool concept. And now if I do this, I actually get the sorted as numbers here correctly with 3, 4, 12, 15, and 21. And here's like the even shorter version of this, right? And we will see this a lot. So this you should really pay attention to. This is the arrow notation. So what this here means, well, I'll repeat it a little bit later, but essentially this means create a function that doesn't have a name, an anonymous function with 2 parameters, a and b, do this operation and return it as its result. And this is the arrow notation, right? So you can see that instead of writing like this function here with a number and then like a signature and then having a return element, all of this here happens in these couple of lines of codes. And this will be something that we'll be using a ton. And if this is like weird, don't worry, I'll repeat it even today. We'll go over this one more time. Yes? Yeah. 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 Well, I can give it whatever name, yes. But of course, I have to use the same name if I use the name. But I can actually like let's talk about this later and I'll talk more about functions. Okay, let's talk about objects. Objects are the next type of data structure. And objects are like everywhere in JavaScript, right? So here is how we define an object. And how objects are treated in like they're also hash maps or dictionaries or associative arrays, however you might want to call them. And they're also objects. So they have this kind of multi-function. There isn't actually anything that's called a hash map in JavaScript. You can just use an object for that. And an object looks like this: key, colon, and value, key, colon, value, right? And these values, again, can be functions or they can be variables. If we want to access an element of an object, we can just run object dot this key here, so key 1. And we can also do this here, object and then square brackets string key 2. The thing is that you should typically not do this. Sometimes you have to resort to it, but typically you shouldn't do this because if I refactor this to be called key 3, right? Then this here will not actually work. You can see that value of key 2 here is undefined. And if I have a good IDE, I don't change this names, right? I refactor something, but refactoring tends not to catch up on strings. Like you can search for, with a good IDE, you can search for strings, but typically this is not the case, right? So you should be wary about using the syntax here, but it is possible. We can also use these keys here in strings. And if you know JSON, then you will recognize that this actually looks a lot like JSON already, right? JSON is this object format that we'll be also using quite a bit. And so JSON files are easily loaded in JavaScript because it's almost the same definition, right? Then I can add objects, and it can extend objects dynamically. So I can take an object and just say new key, and this doesn't have to be specified before. And then I say dynamically added here. So you can do this for any object. You can take the JavaScript array function and then assign a new variable to it, right? You can just say like my array sort only numbers less than 100. You could add a function like this, right? And then you could implement this, or you could add a variable to any object. And then note that unlike for arrays, objects typically actually contain mixed data types, right? Because this is like a defined data structure. It's not like an array where you expect everything to be numbers, but you expect there to be these key value pairs. So it's totally legit to have like name, Alex, birth year, then I have a number, nationality. So those are semantically different, but that's the point, right? This is why objects are good. Yeah. Yes. Because in this case, like, you know, if you have an IDE, this here would look like a string. So your IDE couldn't tell apart whether you're just writing a message to a user or whether you want to change a variable name, right? And so your IDE would try to automatically change that for you. Yeah. Yeah. And that's all JavaScript. That's why the difference between class-based programming languages and prototypical programming languages, right? So that's kind of the weird thing about JavaScript, that every object can be changed at runtime, and every object just has other prototypes that it inherits from, right? But I actually don't have a concept like an interface. That doesn't exist. It does exist in TypeScript, but in JavaScript, you can just change any object the way you want. Okay, let me just here is like an example of a JSON file. I just wanted to show this kind of like duality between JSON and object in JavaScript. Here I have an array, like a JSON object with an array of people, Alex and Jen, and then I have other like things, countries they lived in, when they were born, nationality, and so on. And then I can just parse this, and I'm not going to go into this. You can look it up if you need it. But essentially, what I'm doing here is I'm taking this file here, and I can just very quickly parse this. And I have this object, and I can now inspect this object, right? And can look into the details of it. So this is like a way of how I can store data and how I can load data into these nested and deep objects very quickly. There is really like, this is just all template code that reads this stuff in here. And the only thing that is really interesting is JSON.parse. That's the function that reads the JSON here. And then the other thing that's interesting, that's very common in JavaScript, at least until you start working with promises, is that you have these callbacks. So here we're like essentially calling, like using this read data callback function that fetch JSON file should kind of like later execute this function here. So this is a very common paradigm, that you pass a callback function to a JavaScript function. Okay, let's talk a little bit about control structures. Yeah. Oh, because the function is fully defined. Like here, the function here, or the function, what happens is that the fetch JSON file, this function knows what it expects from a callback function, right? So it has certain conditions on that callback functions, and so they like essentially it wants to like this fetch JSON thing here creates the data parameter that it then passes into this callback function, right? And so that's in the, if you look up the fetch JSON definition, it will have a documentation that it wants a callback that takes the payload of the data. Yeah. Okay. Here we have our familiar control structures. We have like the familiar if. The one thing that's particular about JavaScript is that you should always, like, if you do equality tests in most other programming languages, you use 2 equal signs. In JavaScript, you typically should use 3, or like you should almost always use 3 equal signs, right? And the reason why is 3 equal signs is a comparison that doesn't try to do something weird with type coercion. So, for example, here this will work just fine, right? Parse int to 1, that works fine. If I do this, because this is the shorthand parse operator that converts to number, this also works fine. So all of this is kind of like as we expect. So here, we get into our first if, right? The thing is, like, this here shouldn't actually be true in a sane programming language, right? So if you say 1 equals the string of 1, you don't want this to be evaluated true, but it actually just parses it for you, right? It just tries to somehow make it work. And that can be a good idea, but mostly it's actually not. So mostly you kind of want to be explicit about parsing something, just so that you like don't introduce some weird bugs into your code. If you use the triple equal sign, it doesn't do this type coercion. So then it actually like checks the type. So this will not be true here. So this we don't get in here. So string and int are not the same, and this is kind of the safer, less buggy option. And then another thing that you know probably from other programming languages is the ternary if operator. So we can write this condition, then a question mark, the expression what happens if this condition is true, a colon, the expression what happens if this condition is false, right? This is like a shorthand. So you can say true, like basically it means if I can do anything here, like 1 equals 1, that would be true. And if that is true, this here is executed. Ternary if clause is true, which is what is executed here. And then if we do, and if this were false, this expression, this would be executed. So if I put in here false, then I get to ternary if clause false, right? No, everything after the question mark is evaluated conditional on the result of the condition, right? So the first part before the colon is evaluated if the condition was true. The second part after the colon is only evaluated if the condition is false. Yeah. Say that again, please. It just parses it, right? It tries whatever possible to convert a type into compatible forms. So like it's just like a, you know, like HTML tries to render even if there is mistakes, JavaScript tries to execute even if there's mistakes, right? And so, for example, if you forget to parse it, or if you write sloppy code and you expect a string that is a number, you don't actually have to first convert it for that. That just is the way it was implemented in the beginning. That's why we now have this weird syntax with the 3 equal signs to behave like any other programming language. But that's just something you have to know. And so you shouldn't use that, right? No, it's not. It's typically, it's just like, you doing it suddenly, like you want to be aware if parsing fails. Like you want to, like if you parse, like here, of course, it doesn't matter. But this could be some variable that I read from some remote source, right? Or that the user types in, right? And I don't, like if a user types in an invalid value, right? Like a string instead of a number, I want to know that. And I don't want the program to fail sometime later when I use that variable. Okay. We also have switch. And switch works with string literals. So here is let I some case, switch I, and then we have string literals are okay. We have to do the break thing as we have in other programming languages, right? So the case here are executed until one of them matches. Then either it continues executing or it has a break, right? So for example, if I were to, this here is true. So we can see that this here executed with the switch matches. But if I were to remove the break here, I would also get the default. and that's something that I typically don't want, right? It makes sense in some cases, right? I want some default behavior or some other like evaluation on top of it, but just be aware that most cases you want to break in here, but this is also consistent with most other programming languages. Okay, loops. We have our standard loop with our indices, so we can do things like let I equal 0, I smaller than 10, plus I, right? This is the same as C++ or other languages, so this works just fine. We have while loops. They are also just the same as in other programming languages. So here is our so here's our while loop output, right? So that works just fine. All of this is fairly standard. Then we have these do while loops. They're the same, right? The difference between the while loop and a do while loop is that the do while loop is executed once for sure without checking a condition, right? Whereas the while loop checks the condition first and executes it then. And then this is the interesting piece. So if I have an array, and this is like very common, right, that I want to iterate over some data structure. If I have an array and I want to iterate over all of those elements, traditionally the way you would do this in JavaScript was to use for the array that has like a for each function. And in the for each function, you pass in another function that does something. That's kind of like the JavaScript way pre-ECMAScript 6. You can do this instead, and this is kind of like newish for year of years. And that does the nice thing of like listing all of those years, right? So this is like a very handy function that you often need. The thing is, don't use the for in loops. This is what I mentioned earlier, right? Because the for in loops doesn't actually go through the elements of the array, but go through all of the fields of the array object. And so there might be some stuff in there that is weird, and it might also not be the order wouldn't be guaranteed because the object stores it with hash key. So like it's simply like you can get some weird undefined behavior. I think I need to speed up a little bit, so I'm just gonna jump over some things here. Well, yeah, let me just continue with JavaScript, and then we'll have a tutorial on Friday. And there you'll also get some of the D3 stuff. I don't think, given the pace and the many questions, I really appreciate it. But I don't think I'll cover everything that I wanted to today. But let's just keep going, because I think it would be weird if I jumped over functions and so on now. Okay, so we already talked a little bit about functions, and they're like this key feature in all of computer science. They're like basically exist in every programming language. And JavaScript not only uses functions the way we know them from other languages, but they also allows anonymous functions. And so here's my like traditional function here. And here's how I would use this function, right? And this function returns a number if it's smaller than 10 that you put in. And if it's larger than 10, it returns like the square of that number. And so like easy enough, right? That is kind of no magic here. We have the same kind of thing as we had for like the equality tests. So this number function here wants a number, but actually like it's not really defined, right? Like I'm not saying anywhere that I'm expecting a number because I don't have any typing. So I can just put in a string. And if I do that, you will see that the function for the string that can just be converted to a number will be converted, right? So we have the same behavior again. If a string or any other object can be converted, it will be automatically converted. What happens if I guess what happens if I put in a string? Well, JavaScript still tries to convert it to a number, but says no, this is not a number, and then the result here is not a number. It doesn't say it doesn't throw a runtime exception or an exception, anything like, oh, this is an incompatible type. If you if you call a function with more parameters than it actually defines, JavaScript just takes the ones it knows what to do with, and it doesn't do anything with the rest. So it doesn't tell you, hey, this is not the right signature, this is not the right function, like maybe you have made a mistake here. It just tries to do something, and the who here is just ignored. And if you don't put in any functions, it also doesn't complain any attributes into the function. It just assumes you wanted to put in not a number in that case. So this is kind of like weird. Here's an alternative way to define this function, and this goes back to this a function is a variable that I can pass around. So I can actually say, let variable function be this function. So notice this difference here, right? This is the traditional way of defining a function, the name of the function, the signature of the function. And then here I just say variable function and then say function of v. And this works just as we would expect. So this is the same thing. And I can do this even shorter, right? I can like do this as a one-liner, and I can also reassign that function. So I can say my variable function from now on should do something different, right? And then I simply write a new function and assign it to the same thing, and everything that is executed later with the same function will execute that new function. This here is the key concept, right? That I think I've repeated a couple of times. Functions are values that can be stored in variables, can be passed around, and can be modified at runtime. And then the kind of like to the max here are these anonymous functions, right? This is like something that we will be using a lot. And here's the long version of this anonymous function. So for example, I have a map, like an array here. That array has like the for each loop has like this map function. And so this map function applies a function to every value of the array, right? And so we define this function. The function doesn't have a name, right? This function is only meant to be used this one time. And so we don't actually need to give it a name. And so we say the function takes one parameter that we call d, and then it returns d multiplied by 2. And d here is the value in the array that we're mapping, right? So that would be the first value, the second value, the third value, and then it would apply the function to each of those values and store it in that array. That's the map part of it. And then the anonymous function here does the logic of multiplying it by 2. So the map function here has this callback parameter that we kind of specify here with this anonymous function. And then in ECMAScript 6, we have the super convenient and maybe slightly confusing the first time you use it, but you wouldn't believe that you would grow to love this by the end of this class, the arrow functions here. So this is the same thing as before, right? But instead of doing this here, these 3 lines with all of the curly brackets, I just do d arrow d multiplied by 2. And this is the same thing, right? It essentially says I have one parameter that I call d, and then I do something with the d, and I also return it here. So very convenient, very quick. I can also create like this results in some weird things. So for example, I can do an arrow function with no parameters, assign it a number, and then assign it to a variable. So basically here I now have a weird way of saying f1 is 12. But that's possible, right? Here is a function that multiplies the parameter. So like f2 is the function x multiplied by 2, right? And the other thing is we can have these arrow notations with multiple parameters, and we'll be using this frequently. And the only difference between a single parameter where you have nothing is that you have now to use like the brackets here. That like you have now 2 parameters, x and y, and you can do then some math in that function, but that's basically the same thing. Okay, any questions about arrow functions or anonymous functions or lambda calculus?
Is there any way to do a map with multiple variables?
So the map function wants only one, right? So no, but you could write another map function that or something else that takes 2 variables, right? Okay, now let's talk a little bit about object-oriented JavaScript. And as I mentioned a couple of times, JavaScript is a prototype-based language. And with all these functions as variables, we can actually create fake objects. And so here we have a function create object, and I'm saying let result. And then I'm using object notation. And I have get returns content. I have sets content. And then I have a twice. That's a function that multiplies content by 2. And then I return the result. And notice this is just functions, right? There's no class or anything like that. But I'm actually creating an object here. And so I can actually call now f. I can say f.get, and get will return something. If I say f.twice, then I put in a string, then I get another number. Then I can say f.set put in 20. If I get that, I get 20. And if I call twice, I get 40, right? So this is the way of how people created object-oriented programming based on a purely functional approach before, like essentially objects with methods and variables, right? Before JavaScript had actual support for this. The thing in JavaScript is that it uses prototype delegation. So for inheritance, like I'm sure many of you or most of you know about inheritance, right? In object-oriented programming, you can create a class of, let's say, type animal, and then you create a class type dog, and the dog is inherits from the class animal, right? So it has attributes like or functions like live and die and so on. But then the dog has 4 legs and it can wag the tail, and like this is the kind of example that you've probably seen in your intro programming classes, right? And you can do the same thing in JavaScript without classes. So you can say, here's my object base and my object derived. And so first, what I'm looking at here is, of course, like all of these variables, v1, like notice that v1 here is the same in derived as in base. v2 and v3 are unique to base, respectively derived. And so if we look at this, these are the values that we would expect initially. And then I can say object. This is like a global namespace object that we have that set prototype of derived base. And so now this makes the base the prototype object of derived. And behind the scenes, what happens now is if I were to call, if I have an object of type derived and I call v2, JavaScript will see, oh, there isn't any v2 at my level, but let's check out whether my prototype has any v2s, right? So it will go back one step in the inheritance tree and look at whether the parent has a v2. And if the parent has a v2, it will return that v2. If the parent doesn't have a v2, it will look at this object's parents and parents and parents until you kind of reach the end of the tree. But if it has a v1 here, then the derived one would return. And so this is what happens here, right? So after I've set the prototype here, derived v1, we would expect it to be 5 and not 1. And so this is exactly what happens. 5 accessing the overridden v1 in derived. But if we ask derived for v2, that wouldn't be possible if we didn't have the prototype set, right? Then we can see that v2 is accessible and gives us the correct result. So if we copied this line here, up here, then we would get then we get an undefined here. So does that make sense? This is kind of like how inheritance works in JavaScript. And then on top of this, we now have actual familiar class syntax. But the point is, this is really behind the scenes, JavaScript still works the way I just showed it. Classes are really just syntactic sugar. And so I can do your class base with your constructor. I can put parameters into the constructor. I can use this with this keyword, assign these to these class variables. Then I have a method that returns this first multiplied by this second. And then I can do this. I can like call this. And then I can extend this class. I can create a class derived that extends base, that takes has a third parameter. It calls the constructor of the superclass of the parent. I'm assigning a third variable, and then I'm overriding the multiply method to include the third variable here as well, right? So this is like, should be fairly familiar syntax to everybody. And so this is kind of like a nice way of doing class-based programming and inheritance in JavaScript. Of course, it wouldn't be JavaScript if there wouldn't be something weird about it. The weird thing is this variable this, and this is what I've used here to access the kind of object scoped, class scoped variables. And in most programming languages, this is always refers to the scope of the kind of like, where something is contained. But in JavaScript, it actually refers to the scope where something is called. And so we can do something weird with it. So here, what we have an other object that has like an x and a get and a set. And here we call other.x and other.get and other.set. And that all works. But the problem is here in this example here, what we're doing here is we're reassigning object.get, this function, we're reassigning it to a new variable, right? Because we can assign a function to a variable, we can take an object, take its function that it contains, assign it to a variable outside of that object. And now we would assume that t, if we call t, it would actually do object.get, but it doesn't do that because t now has a different scope. So this here means something different. In this case, it actually refers to the method, or like to the window, which is like this object in JavaScript that is the browser, essentially the browser window, right? And so that's now the context, not the object anymore. And so we get this window instead of the simple getter function. So this is just like a warning that this can be kind of weird. I know we're out of time. I just want to point you to, here are some other cool things about JavaScript that you don't strictly need, but are neat. So for example, you have lazy expressions. So you can, for example, do default parameters, or you can even set a function to a default parameter. You can do gather and spread operators. You can do array destructing. So for example, you can do something like this. If you know that that a function returns like an array of 3 elements, you can say let x, y, z in this array and give it the foo, and then you can use x, y, z as independent variables, right? So there's like many other examples like this that you can just look through here. There's some more documentation. And so thanks for the patience today. I will be talking about D3 on Tuesday. You should like go to the tutorial if you want to get started early on the homework. Otherwise, I hope that it will be sufficient to get into D3 on Tuesday. Thank you. Sure. Let me just stop the YouTube stream.